In this episode, RoboTF opens up his own wallet to try to satisfy his viewers and brings in an AsRock Intel ARC A770 with 16 gigabytes to stick through the Mistral leaderboard test. How's it going, everyone? Today we're going to try out another new architecture. We'll bring in the Intel cards, and yes, I did open up my own wallet from selling some of the 4060 Ti's to your viewers, so thank you viewers for making this happen for the community. Here we're checking out some of this box. Let's go ahead and pop this thing open so that we can check out just how pretty this AsRock card might actually be. Ooh. Pretty black box. Not bad. Not bad. Alright, let's get this thing open. Check out what nice special things they sent with it. If the box just cooperates, just open. Just open. Give me my GPU. Yeah. Alright, we have an important notice. Right on top. Yep. We know what to do with important notices. Yep, instruction, quick installation guide. Yep. And what we got is the card. And only the card. No power plugs, no nothing else. Here's it out of the box, nice and pretty looking. Just for size reference, that's a 4060 Ti and a 4070. And up here, this is an A4500. About the same size, maybe a little bit bigger. Triple fans. There's your power. Here's the backs, just so you guys can check out what it looks like. If you're building a system and you're looking for, looks, gotta have everything looking good. Let's go ahead and get it in the system. Here we go, and let's power this up. And ta-da! Alright, let's hop to the lab, guys. And welcome back to the lab, robots. I'm not going to lie to you all, I've actually had this AsRock Intel A770 16 gig in the lab for several weeks now. I've only had time to play with it on the side, and frankly, this card was a super pain in my butt to get it actually working and functioning well enough with software like llama.cpp. I could not get it working with local AI correctly and ended up having to update the Intel oneapi to even get this thing to recognize correctly, along with compiling llama.cpp from source. But under the hood, this is basically still the same exact testing that we've been doing for the Mistral leaderboard all along. So let's go ahead and hop in and take a look at this card that we are going to be running through the Mistral leaderboard tests today and see what it's all about. Now, this is the exact card that I purchased for, I think it was $289 when I bought it. It was on a little bit of sale, but this is an AsRock Intel ARC A770 graphics Phantom gaming card with 16 gigs of VRAM. Let's go take a little bit better look at the specs of this thing. It was released roughly at the end of 2022. It has a TDP of about 225 watts on it. And of course, it's got 4,096 cores, 16 gigs of GDDR6 VRAM at about a 256-bit bus, along with about 2200 megahertz clock speed. It's supposed to boost up from there, but we'll see how it goes. So on paper, this thing has got pretty decent specs to it. Let's see if it actually lives up to it and where it might actually rank against some of the CPUs or the NVIDIA GPUs or other stuff that we have on the leaderboard. So let's go ahead and hop right into this testing. This is going to be slightly different, as I mentioned, because we are not using local AI, but we are going to use my testing platform, and we're going to run llama.cpp server behind the scenes, which is basically what local AI runs anyways. This is configured to be using Sycl, which is hardware acceleration software For the Intel ARC series, we are going to be running llama.cpp under the hood with it compiled for Sycl, and we will get full hardware acceleration from it. And you can see over to the side we are actually watching this. Again, these drivers and stuff in this card are so new that it still has problems with different Linux, but we'll be able to get the power over here from XPU SMI, and this down here is Intel GPU top. Not as good as NVIDIA top, don't expect that. The software just isn't up to speed with like what NVIDIA delivers, and that's why a lot of people go NVIDIA. However, we will still be able to see most of these metrics that we need to see to get a good idea of what we're going at. Let's go ahead, and I am going to stop it from my previous playing. You guys will actually see the server process drop off down here. And we are going to go start with our normal Mistral Q3 Quant, and we will run it at the same exact 20 tests using our 111 token prompt, and then we will take the averages of those and look at the report at the end. But remember, we're going to do Q3, we're going to do Mistral Q4, Q5, Q6, Q8, and FP16 on this card, and see how it turns out. I'm really interested to see where it lands on the leaderboard, understanding that Sycl and the drivers are still basically kind of in flux for these cards, but they're getting better all the time. So we can see how it actually is going to end up performing and at what watts, and see if these are good cards for the money. Let's call this MLA 770 Q3. Go ahead and hit enter. And let's start the server back up so we have nice fresh logs. Make sure our report's still in there. We've got Q3 selected. We're going to use our same 111 token prompt. We're going to run it for 20 tests, get the average of those tests. I'll also show you guys the full report of this test at the end, but just remember we're going to do Q3, Q4, Q5, Q6, Q8, and FP16, and then we will come back for those results. Let's go ahead and get this kicked in. We can see off to the side it's using about, so far, 153, 154 watts. Fairly decent. Seems to be moving pretty quickly here. What do you guys think of Mistral 7B at a Q3 Quant running on this Intel ARC A770? Not too shabby. First test over. Let's wait for it to gather the results. This is a little bit slower than what it is during our normal test just because of the way that I have to run this. So the first one back at 21.52 tokens per second. Let's go ahead and kick this into fast forward mode, and I'll see you guys at the end of this one and setting up for Q4. And this is the last bit of Q3. It's been pretty flatlined this whole time, which has been quite impressive. And I'm running through these tests with you guys, the full tests, for the first time as I'm recording this. So a lot of this is actually going to be new to me. I was just making sure we could get this thing running. So let's see where it settled out to be. Yeah, pretty flatlined at about 21.5 tokens per second. All right, let's go ahead and generate that report. And then I'm going to go ahead and stop the server, just so that we clear out all the logs and the processes. And then we are going to go ahead and select the Q4 model, change up our report name. And start the server back up with the Q4 model. And we will jump right in and see how Q4 performs. Any guesses, guys? And there goes Q4. The last test we saw about 157 watts peak. So this is Q4, and right off the bat it looks like it's using about 161 watts. Let's see what this first one came back at, and then we'll hop right into fast forward mode. Oof, 28.69 tokens per second on the Q4. Let's go ahead and kick it into fast forward mode, and we'll come back for Q5. And here's the last bit of Q4, just cruising right along. Again, paying attention, I've seen it use about 163 watts or so max. That's probably as the fan spools up as this gets warm. But it still felt quite good to me, and it was running at about 28, just over 28.5 tokens per second. Finishing off at, look, 28.79, 28.76. That's pretty good and also interesting because that's quicker than the Q3 model, which is a little weird, but let's see how this keeps going. Let's get that report generated. There's the report for Q4. Let's go ahead and stop the server and make sure that we move over to Q5, and let's see how that starts out. Q5, change the name of our report, hit enter. Let's go ahead and start the server up so that's got the Q5 model loaded, and we'll get right into this. Same 20 tests. Let's see how Q5 feels. Feels pretty good to me. Cruising right along on this Intel ARC A770. Add a Q5 quant, and remember this has got the same context size. I forget, I think it's like 12K that we run on all the other tests. I tried to set the server up to mimic exactly what we do with all of our NVIDIA cards. So it should be pretty close results. Let's see what this first one comes back at. 21.67 on the Q5. All right, let's go ahead and kick this into fast forward mode, and we'll come back and take a look at Q6 next. And here's the last bit of the Q5 tests. Still seems to be cruising right along. Saw about a top of 167 watts during this test as it's going up and using slightly more VRAM each time. Finishing off at about 21.68 and 21.67. Again, right in that range. Let's go ahead and produce that report. And we'll stop the server and get this all set up for the Q6 run as we start to get into the much larger quant sizes of Mistral 7B. So let's go ahead and make sure that we get the Q6 model selected this time. Change our report name. Let's go ahead and start the server back up with model Q6. And we'll get right into this. Same prompt, same 20 tests on Q6 on the Intel ARC A770. Let's go for it. Looks like it's cruising right along right off the bat. GPU power is up to about 167 watts. I assume we'll see that. There it goes, 168, climb a bit. Let's go ahead and see where this first one ends up, and then we'll kick it into fast forward mode and come back for the Q8 test. First one back at 26.68. Alright, let's kick it into fast forward mode, and I'll see you guys for the Q8 test. Alright, and Q6 finishing off at about 26.7 tokens per second. Not too shabby at all, not too shabby at all, but slightly interesting. Let's go ahead and produce that report, and then we'll get set up for the Q8 run, because I'm very curious to see how that's going to turn out. Let's go ahead and get the server stopped. And remember, this is with the Sycl backend, not Vulkan. So I could try that too, but I was focusing on the Sycl one because that's what I had assumed was going to perform better. I may be wrong on that. As always, your results may vary also. Okay, we've got the Q8 selected. Let's change up the report name and start the server with the Q8 model. And let's kick this test off. See how Q8 feels. Moving quite well for the Q8 model. Power to start with says 148 watts. 149, I'm sure it'll go up a bit. Let's go ahead and see where this first one finished off on the Q8. 17.14 evaluation tokens per second. Let's go ahead and kick it into fast forward, and I'll see you guys for the last and final round, which is the FP16. And here is the end of the Q8 test, still moving right along on this Intel ARC A770. Let's see where this finished off to be, but it was trekking again about 17 evaluation tokens per second while using 149 watts. Let's go ahead and get this report generated. And then we'll go ahead and stop the server and get this all set up for the FP16 run and see how this card ends up actually performing. Find the FP16, change the report name. Let's go ahead and start the server back up with the full FP16 version of Mistral 7B, and we'll get this party started. Alright, this is the full FP16 on this AsRock A770. Yeah, I can't get that right. Who cares, right? Can't pronounce things. Doesn't matter. This is the internet. Everyone will make fun of you anyways. Cruising right along. Let's go ahead and see where this first one ends up. This feels pretty quick for FP16, which is interesting. Wait for that first result. 17.32. And if you look over at the wattage, we're using about 144, 145 currently on FP16. Let's kick it into fast forward mode. We'll come back at the very end, gather all of this up into one report so that we can see all of the different specs across the quants. And then we'll see where this A770 lands on our Mistral leaderboard. See you guys in just a few. Alright, and that was the very end of FP16 and our full suite of tests. It came in at, again, just over 17 tokens per second on FP16, which is basically the same speed that it ran Q8 at. I firmly believe that there's some issues with the software and integration still with these cards. I know Intel is working on them and making some pretty good advancements, but I don't think it's necessarily the card's performance, but the software and the integrations in between. But you have to admit that's interesting. So let's go ahead and get that report so that we can take all of these reports and bring them together in one. Let's go ahead and expand this out so that you guys can see a lot better. And we're going to go take all of those reports that we just ran and combine them into one big one. Ooh, did I whip right past it? Yes, I did. Okay, so we've got Q3, Q4, Q5, Q6, Q8, and FP16. This is the ML ARC A770 at 16 gigabytes. Let's combine those files and we'll go take a look at this report and see how it actually turned out. Scroll on down and right there. Okay, so this is the prompt evaluation time. And just so that we can go over it, in brown is the FP16, purple is the Q8, red is the Q6, green is the Q5, orange is the Q4, and blue is the Q3. And you can see the evaluation time on this was pretty tight. Pretty tight. And this is the actual evaluation time. You can see some interesting patterns starting to come out. But I'll leave it up to you guys to interpret this and what you see here. The total time is going to be those two put together. Prompt tokens evaluated should be 111 across the board like all of our tests. Completion tokens. And then total tokens across the board. And the prompt tokens per second. Now let's go ahead and take a look at the evaluation tokens per second. Again, most of these tests were quite flatland with using llama.cpp directly with Sycl as a backend. Now what's interesting is if we look at the bottom, we've got brown is FP16, Q8 is purple. So we can actually see the FP16 was just a hair faster than Q8 on this machine. Now if you hop up, you see another pattern, which is we have Q3 and Q5 at just below 22 tokens per second. And then if we go up, we have Q6 and Q4 at the top of the list. Now, again, I'm giving you guys these tests right out of the box as much as I possibly can. This was compiled with a newer version of the Intel oneapi kit, but not the newest one. And that's because some of the software didn't actually support it. But anything previous to that one, this card would only show up at 255 megabytes, and obviously that wasn't going to run any model. So I had to get a specific mix of drivers, the oneapi kit, and llama.cpp to be able to make this actually run. But this is some interesting results. I'm sure as the technology evolves, this will actually get much better. But let's take these results, because this is just how we run these cards, and let's go add these results to the leaderboard and see where this actually lands. Give me just a moment and we'll do just that. Just for everyone's sakes, you can always come to RoboTF.ai and see the current leaderboard, along with, if you want to see any of the reports from any of the videos during this series, you can come get it from right here and see it for yourself so you don't have to look at my screen. So here it is, Mistral 7 leaderboard. Where do you guys think that Intel ARC card is actually going to end up landing on here? And hopefully we don't crush too many hopes and dreams as far as it goes. So this is the current Mistral 7B Q3 leaderboard. And if we look down here, that ARC A770 came in 7th place, just under the MacBook Pro. Well under the MacBook Pro. Look, 21 tokens per second at about 155 watts. So for those of you who are very curious about where this stands up to the 4060 Ti, which is a bit of a more expensive card, yeah, look at that. Okay, let's go ahead and take a look at Q4, see if that's much of the same story. And yes, it is. It's down here at 28 tokens at 163 watts, sitting in between the MacBook Pro and the Tesla M40. Still pretty decent though. Let's look at Q5. Yes, much of the same story. 21, over 21.5 tokens per second at 167 watts, but still well under the MacBook Pro and that 4060 Ti. Let's go take a look at Q6 now. Oddly catching up, isn't it? But still in 7th place currently on our board at 26.7 evaluation tokens per second, using about 168 watts. Alright, let's hop over and take a look at Q8. Again, much of the same story, right? 17 tokens per second at 148 watts in 7th place, but still well behind the M1 MacBook Pro and the 4060 Ti. This one is going to be a different story. We know that from that last run, and also why I think that there's still issues with the Intel drivers, Intel oneapi kit, along with support from llama.cpp and say local AI, which will need to compile with those new versions of the Intel kits. But look at this. 6th place, beating the 4060 Ti on FP16. Just barely beating it, but look at that. 17.35 tokens per second versus 16.77 on the 4060 Ti. Using a bit more wattage, but still, that makes me think, again, that these tests have a ways to go as the software actually catches up to this card itself. Very, very interesting. Tell me what you guys think down here about this. Obviously, come take a look at the tests. I hope you guys actually enjoyed this one. This one was a super just pain to try to get this to actually function, which is also why, you know, again, I think that there's some software and integration issues along with these cards, but look at that. Not bad, Intel, not bad when it comes down to FP16. Not bad at all. Hope you guys enjoyed this. If you do me a favor, hit like, hit subscribe. Also, remember, buy your AI pizza. AI, what in the heck am I going to do with this Intel card? Oh, you want it as part of your brain, huh? Well, let's talk about that. Maybe we've got some more resources that we can use this thing for, or some more tests. What do you guys think we should do with this Intel card? Let me know. Until next time, see you guys later.